This is Stepping Stones lesson 7.10. We are doing common fractions and we are finding the difference between mixed numbers by decomposing whole numbers. So step in says Andrew has two pet lizards. One is 3 4/8 inches long and the other is 1 7/8 inches long. How could you figure out the difference between their lengths? Laura figured it out as shown on the right. What did she do to make the subtraction easier? So this is where we talked about the way that Stepping Stone shows this, I think is a little confusing. So I'm going to break it down a little bit farther. So if we set this up how I showed you yesterday and we do it vertically instead of horizontally, we can sort of see what we're doing a little bit. So remember, we're always going to move right to left, just like when we do regular addition or subtraction. Now, in this case, we have 4/8 minus 7/8. Yesterday, we didn't have any issues with this, but if our number on top is smaller, we can't just erase straight across, subtract straight across. You can't flip it like we do with addition and do 7 minus 4. So just like in a normal problem, like for example, if this was 34 minus 17, we would have to decompose this 10 or borrow a 10 and move it over. So that's exactly what we're going to do here, but with fractions, it looks a little different. So I'm going to use a different color and probably not blue because we're on blue. I'm going to use purple. I'm going to cross out this 3 and it is now a 2. Now, this is in my ones place, but I'm dealing with fractions over here, so I need to represent this whole that I'm borrowing as a fraction. So I'm going to add 8/8 because 8/8 is 1, and I borrowed 1 whole from this 3, and now this is a 2. So that makes this now 12/8. Sorry, I'm on the edge. So this number is 12/8. That's where Laura got this 2 and 12/8 from. Now, earlier I told you you can't leave your mixed number answers as a whole number and an improper fraction, and that's true, and our answer will not be left as a whole number with an improper fraction, but when we're doing our math, we can set it up this way. So I'm going to rewrite the problem so it's a little clearer now. It's the same as saying 2 and 12/8 because I borrowed that whole and just turned it into a fraction, minus 1 7/8. Now I can do my subtraction straight across. So I'm going to do 12 minus 7, which is 5. And that's 5/8 because we keep our denominator the same. And then 2 minus 1, which is 1 5/8. They represent it on the number line. And so the way that they did it was actually by working backwards and doing addition. So we're starting with 1 7/8. We're adding 1, 1/8, 4/8, so 1 5/8. And we can check our answer. And we did get to 3 4/8. So that's how we know that our answer is correct. Okay. So step up says calculate the difference, draw jumps on the number line to show your thinking. If the number line does not help you, please don't feel like you have to use it. I'm going to use red. So we have 3 2/6, 3 2/6 minus 2 5/6. So we're in that same predicament that we were over here. We can't take away 5 from 2, so I'm going to need to decompose or borrow. So I'm changing this to a 2. I'm going to borrow 6/6 because I borrowed 1, and I'm just putting it in fraction form. So now I have 2 8/6 minus 2 5/6. And so I can just subtract straight across. So I get 8 minus 5 is 3/6. And 2 minus 2 is 0. So my answer is just 3/6. Now I am going to show this on the number line just to help you. So I'm going to work backwards from my answer. So 1, 2, 3, 6 is where I'm starting. 3, 6. And I'm going to jump 8, 6. 1, 2, 3, 4, 6, 7, 8. And that puts me at, you know what, this isn't the best way to show this. So I'm going to start over. Okay, so we're going to start at 3 and 2/6. And then I'm going to subtract 5, 6. 1, 2, 3, 4, 5. And then I'm going to subtract 2 wholes. So I'm going to subtract 1 and 2, and that puts me at 3, 6. So you can see from the number line, I did start at 3 and 2/6, which is where we started. And then I just took away 5, 6, 1, 2, 3, 4, 5. And then I made 2 big jumps. So that's another way to solve it because I took away 2 wholes. That's another way to solve it if changing this is a little confusing to you. But you can also see, I like to imagine it as just counting on. So I do 2 and 1, 2, 3, 4, 5, 6, 6, 2 and 7, 6, 2 and 8, 6. So they are equivalent. Let's go on to page 2. Okay, same thing. We have 5 and 1/3 minus 2 and 2/3. And I can see that I can't subtract 2/3 from 1/3, so I'm going to borrow or decompose. So this is a 5 plus 3/3 now. I'm just moving this over into fraction form. And I write the plus sign because it helps me remember that I need to put those two together. If that doesn't help you, that's fine. You can leave the plus sign out. But now I have 4 and 4/3 minus 2 and 2/3. So I do 4 minus 2 is 2/3. And then 4 minus 2 in the wholes is 2 and 2/3. So my answer is 2 and 2/3. And we can show that by doing 5 and 1/3. And then jumping back 2/3, 1, 2. And then jumping back 2 wholes because I subtracted 2/3, and now I'm going to subtract 2 wholes. So 1, 2, and I'm at 2 and 2/3. Go ahead and do B on your own. Remember, you don't have to use the number line if you don't want to. That's fine. So 3 says to calculate the difference, and it doesn't give you a number line this time. So we're going to just stack it like we normally do. I'm going to just sort of X that out and set it up over here so I'm not writing over and over again. Okay, we can't take 4/6 from 1/6. So I'm going to cross out the 7. I'm going to borrow 6/6, which gives me 7/6. And then I'm going to subtract 7/6 minus 4/6 is 3/6. And 6 minus 2 is 4. So my answer is 4 and 3/6. Now down here on F, so you're going to do B, C, D, and E on your own. On F, we have 5 minus 3 and 6/8. Now, if there's nothing in this fraction area, we're still going to need to borrow. So we're going to borrow, and this will turn to a 4, and then this becomes 8/8 in this area. So we would have 4 and 8/8, which is equivalent to 5. And then 8/8 minus 6/8 is 2/8. 4 minus 3 is 1.